Hello everyone, welcome back to my channel. Previous video talked about the implementation of insertion sort and merge sort. This video we are going to analyze the time complexity. What is time complexity? The time complexity is to study the relationship between input size and runtime. Intuitively, when the input size getting larger, the runtime will also getting larger. We want to know how the runtime grows with the input size growth. So this is also called order of growth. In this analysis, there will be two assumptions. We assume each instruction's runtime cost is constant. The instruction is run on a single processor and using the RAM model. This is a random access model, which means there will be no parallel computing. So we have the basic knowledge. Let's check the code. In this code, the n is the input size, and we want to calculate the runtime. We can write down this equation: t n will equal to the first line. We assume the instruction is a constant time, and how many times it will run? It will run through 1, through 2, 3, 4, 5, till n, and n plus 1. So this one, it will check this condition and exit the loop. So you have to consider the n plus 1 in the for loop. So it will run n times for the first line. Okay, then for second line, because it's inside the loop, it will not check the n plus 1 because when n plus 1 is already at exit. So how many times will this line run is from here. It will be C2 multiplied by n minus 1. The third line is the comments, so it's 0. The fourth line is same as the second line. So you have a constant time multiplied by n minus 1 time. Plus, this part become tricky because we don't know how many times the while loop executed. Because in different case, it will execute different times. You can be 1, 2, or 3, or several times. So here we need to define a variable called ti, which tells us how many times the while loop executed. Okay, in that case, we have the constant time of the while loop multiplied by the summation of the while loop executed times. Okay, it's start from I equal to 2 to n, and then you have times. For the line 6, we have the same thing, C6 multiplied by I equal to 2 till n. But here we do not sum the ti, we do the ti minus 1. It's the same as the for loop. The while loop, it will also check the n plus 1 times. So the inside the loop, there will be always 1 time less than the check condition. Okay, then for 7, we have the same thing. I equal to 2 till the n, minus 1. For the 8, we'll say 8 multiplied by n minus 1. Okay, so this equation is the time complexity. And as you notice, the ti is a variable, it's not a constant. So we will have a best case time complexity and a worst case time complexity. Okay, what is the best case? The best case is this loop always execute once. So this whole block will become C5 multiplied by n minus 1. This is the best case. How is it possible? It is possible when this condition is always false. That means the key is always larger than aj, which means if I want to insert the key to the pile, it will never loop through the pile. It just appended to the end. So in this case, the best case will be the sorted array. If the input is a sorted array, it will be the best case. And the runtime will be replace this part with this equation. It will be linear time. Because this equation will always return into a multiplied by n plus b. It's a linear equation. Okay. In the worst case, we want the while loop executed as many as possible, which means this one will be always true. So how this happened, it means the key always smaller than card in hand. So this one we always insert the card to the front, so it always loop the card in hand. This one is the reverse order. Okay. If your input is a reverse order sequence, it will have the worst case time complexity. All right. In the worst case, the Ti here will equal to I, because this case is always true. So you only check this case. So when I equal to 2, you have j equal to 1, and how many times it's executed is 2. So when I equal to 5, it will execute 5 times. When I equal to n, it will execute n times. So when Ti equal to I, it will be a worst case. Okay. So we rewrite the function from here. So I equal to 2 to n and the Ti. We remove Ti and change to I. So this is the time complexity of the instruction 5. All right. And this one can be converted to I start from 1 to n and I minus 1. Okay. This term can be written as 1 plus 2 plus 3 plus 4 till n. And this sequence was solved by adding the head to tail. So you add this first one to the end and the second to last to the second. And you can get n plus 1 plus n minus 1 plus 2, etc. And how many terms you have here is n divided by 2 and multiplied by n plus 1. So this one is the final worst case time complexity. It will be square. We have the worst case n squared. It's a quadratic time complexity. Okay, thank you for watching this video. In next video, I will talk about the merge sort time complexity analysis. It uses a different approach because this one uses the divide, conquer, and the recursion. See you next video. Thank you.